So to apply NPR, there is an NPR button on the calculator. Okay, so you can use that NPR button, and the way we would input it is for the last problem where we had eight possibilities and 3 selections where order does matter, we can do 8 NPR3, and it will use this formula 8 factorial over 8 minus 3 factorial or 5 factorial. And that will allow us to only count the first 3 items. So this NPR is used for order matters. Okay, so when we have rank implies order. So here we have a situation where we have a president, a vice president, and a secretary. Now these are distinct people, and they have the order in which we select president, vice president, secretary will matter. So for example, if we had Sally, Albert, and Wanda as president, vice president, secretary, if we switch these around, it's a different situation. So this is a situation where order matters. So we're going to use NPR to do a problem like this. So we have, out of 20 people in the class, we're going to select a president, vice president, secretary. So we're going to select 3 people. So there's a few ways we can do this now. We can do this as 20 for the president. We have 19 people left over to select for the vice president, and 18 people left to select for the secretary. And that will give us the total number of permutations of president, vice president, and secretary. So if we go 20 times 19 times 18, we have 6,840. Okay, so we can do this, and anytime there's descending multiplication, really this is a situation where we have NPR and order matters. The descending multiplication counts combinations where order matters. So we could also use a formula. We can use 20 factorial over, and we can get rid of the 17 that we don't use, okay, or 20 minus 3 factorial, and that will give us 6840. We could also plug this into our calculator and do 20. So this is a third option. We could do 20 NPR3, and that will give us the exact same result. So in example 3, it says a horse race, we want to be able to pick the order of the first 3 horses. Okay, so that's 10 horses running at a time. What are the odds of randomly picking the correct top 3? Well, there's only one way of doing it. So if we can calculate the number of combinations or permutations of the top 3 in order, okay, so in order matters, then we can work out the different possibilities. So for the first place horse, there are 10 possibilities for the first place horse. For the second place horse, there are 9 left to finish second. And for the third place horse, there is 8 horses left to pick for the third place horse. So we end up with 720 possibilities. So the odds are going to be 1 out of 720. Okay, so the probability of 3 horses correct is going to be 1 out of 720. Okay, and again, because this is descending multiplication, it is NPR, so we can just do 10 NPR3 to get the exact same solution.